So, both parts of the exam, the in-class and the out-of-class. Very nice. I love this. Very nice. My hair's changing in here. This is great. I think I should do something different too. In-class and out-of-class, intro, prop stat, measures of center, measures of variation. So both sections. The difference between the in and out of class is the type of problem. The out of class, I'm putting together an Excel-based, for about 2/3 of the out of class is analyzing my chicken's egg production from a measure of center, and it's highly dependent upon Excel. I'm assuming you've never turned it on before, which is probably not true. I bet you a bunch of you have used Excel before, but I'm coming at it as if you never have. So I'm putting together a thing with a bunch of screenshots and a bunch of commands and a bunch of stuff you can copy and paste, which will make it much easier if you're either have never used Excel or have not used it much. The rest of the out-of-class exam analyzes the part of fitness testing from Total Fit, where we do as many victories as we get in 15 minutes.
Oh, really?
So it's a little application of average to average speed, which we don't talk about very much in here, but it keeps cropping up in Total Fit. I'm like, you know what, people actually care about this. So you've got two main problems to do on the out-of-class exam, one of which is analyzing chicken's egg production, one of which is analyzing average speed, or average time taken to run a certain distance. All of it is well explained in the take-home. I'll have it posted at latest Sunday afternoon. I'm going to try to get those things posted tomorrow morning. So that way you have almost 2 weeks to find time to work on it. You're not going to need 2 weeks to do it. I mean, it's like a project. It doesn't take you 2 weeks to knock those out. But I'll give you 2 weeks to find the time you need to knock it out. The in-class part, like I said, I'll give you more details. I'm slipping through that right now. I'm collecting new data sets, trying to keep stuff current, updating things. And that'll be Thursday in class for about half the class. It won't take you very long to knock that thing out in class. We'll spend about an hour doing that, and then do some more analysis of relative position, which we'll be into by then. Project, how was it? All right, decent. No math, right? No math. I mean, dividing two numbers to get a percentage, essentially, and that's all probability is. That's all it is. This was really basically the big idea here was to make sure that you know a couple terms. And just the idea of what it actually is, the idea of a long-run average. So what it means when someone tells you, there's like a 10% chance of you getting hit when you walk out of your house by a car, right? Okay, well, first of all, it's not true. But secondly, if it were true, that would mean out of every 10 trips you take out of your house, you're going to get hit 1 out of the 10 on average. On average. And the danger of that, of course, is it's a weighted average. Just like you guys were talking about before. These guys use weighted average in chemistry. They make me so proud. But it's a weighted average. When somebody says something like, there's a 10% chance of getting hit coming out of your house by a car, what they've done is they've collected data all over the place of people that have walked out of their house and kept track of whether or not they get hit by a car. And in 10% of those times, they have been struck. Well, what that ignores, and this is a danger of probability, what that ignores is the fact that maybe in a whole chunk of that, they were recording data in a place where people come screaming through and don't stop at stop signs. In other words, the average is getting skewed towards the few outliers that might exist. This does happen. I hear it all the time. I bike commuted for years. I bike commuted for a decade and a half. People always tell me, oh my God, you're going to get hit. I'm like, no, I'm not. Because I am most likely not to get hit. Yes, I might get hit. It's much more likely that I'm not going to get hit. And then they start quoting numbers. Well, I heard that 1,000, 1,200 bikers got killed last year or something ridiculous like that. I was like, I'm not doubting that. I'm not doubting that. Let's go deeper. Which ones got hit and why? Oh, these 60 were riding down the street the wrong way. These 50 were on the sidewalk going the wrong way. These 50 were on the sidewalk going the right way. I just read a disturbing fact, not a statistic today. My dad sent me a link of a specialized bicycle, $6,000 bicycle. It's got a battery pack. You can charge it, and it's like a hill assist, basically. You go up a hill, you flip the battery on, and it goes like 35 miles an hour. That's terrifying. Yeah. You put somebody that doesn't know how to handle a bike at 35 on a bike that can go 35. It's like putting me on a motorcycle. Dangerous, right? And the first thing I read was these things are legal to ride on sidewalks. 35 miles an hour on a sidewalk. What's going to happen to my accident rate as a bicyclist? It's going to shoot up. But I have nothing to do with that rate. You see what I'm getting at? Yeah. That's the danger of those percentages. Yeah, Kate.
You were saying it's legal?
Yes.
Where
in some states. Oregon's not one of them. I know, Oregon's not, but there are some states. I don't care. As long as one state says it, I'm appalled. Yeah. It's called a sidewalk. The bike lane is next to it. If there's not a bike lane, that sucks. You ride in the road like I did in the East Coast.
And in Oregon, you're only allowed allowed to go 20 legally.
20
miles per hour.
Oh, is that a law?
He works at an electric bike shop.
I didn't know that. You can't, so an electric bike can be in a bike lane, but it has to go under 20.
Yes.
That's legit.
To be categorized
As a bicycle, not a moped or a motor. That's legit. Okay, I'll buy that. I'll buy that. I'll buy that. Because I used to kick, you know those guys on the gas scooters? I kicked them out of the bike lane. Like when I see them, I'm like, get the hell out of my bike lane. They're like, what? I'm like, you're not a bike. You have a gas engine, for God's sake. Here's my gas engine. Get the hell out of my lane. Huh? And I stand there until they get out. And then I ride away. And then they probably get back in, but whatever. It's my little soapbox. Anyway, the point in fact is, you start letting those on sidewalks, accident rates are going to go up. By definition, they're not going to go down. At best, they're going to stay the same. At worst, they're going to go up. But then my rate of accident as a bicyclist goes up because that thing is termed a bicycle. You see what I'm getting at? It's the danger of a rate that's quoted out of context. Natalie, go ahead. You're going to say something.
No, I was...
Oh, I thought I saw you. I saw this. No, it's okay. It's okay. So that's the danger of them. The danger of any average. Anytime you use the word average, you have to talk also about the spread around that average, which conveniently is what we're smack dab in the middle of doing right now. That's very nice. We're smack dab in the middle of doing that right now. So let me get some markers. Remind me. Why? Okay, measures of center. This is where we were, and of course we'll always be. We'll always be here. Because we like wrapping up data sets with a data point that's in the middle. We like that. It's very, very nice. But to ignore this, measures of variation, is kind of awful. It's kind of awful to ignore that. When I left you on Tuesday, I had tortured you because I made you calculate a standard deviation manually. And I could just watch the energy level dropping in the room as we went. It just always happens. And it's okay. It's okay. It's one of those things, it's a good kind of hurt. Because it's the kind of thing we all need to see how to do. It's important to know, for example, why that sum of that one column always sums to zero. The sum of the deviations from average sum to zero. You have to see that to know why the hell you would square the data results. I mean, otherwise it's just more mathematical magic. That's what a lot of students feel like. Math is some language that's just a bunch of rules you have to follow for no real reason. There's a reason for every single one of them. But you don't see them until you really uber analyze them sometimes. However, I will never make you do that again because it was cruel and unusual punishment to do it more than once. Doing it once is unusual and definitely not cruel. It's unusual to calculate standard deviation by hand. I guarantee that fewer than 1% of 1% of 1% of Americans have ever done it. So consider yourself in a very small, exclusive group. I also think that to do it a second time is patently absurd. So, I want to recalculate Ernie's standard deviation using technology. Now I have to use a TI on the computer because we don't have an overhead projector in here. That's okay. Let's do a new TI plus. There we go. So if you guys bust out your TIs, let's see if we can see this okay. I think we can. This might actually be better because we'll see the button pushes too. Yeah, this isn't bad. Oh good, this is very good. 83, 84, same machine. If you got an 83 or an 84, it's the same machine. 86 is going to be a little bit different, Andrew. At break, we can figure this out. You probably figure it out on your own. But there's definitely similarities. So, if you remember, actually I don't remember. Oh, I got it right here, I don't have to remember. Ernie's test scores, he had test scores of 80, 81, 83, 79, and 82. And Bert had test scores of 100, 68, 82, 94, and 61. Here's what I want us to do. I want us to crunch these numbers using the TI versus manual. You can get the average, the median, the standard deviations, all that stuff by hand. That's great. And here's how we do it. Grab your stat button, which is this guy right here. Just fire him up. And you want to edit. This is your main screen of your stat. And we're going to use these other commands, sort and clear list and stuff. We'll use all those from time to time. But right now you want to edit. So either 1 or enter. Either 1 or enter will get you there. At this point, make sure you're all looking at this. Does anybody have anything in those lists? Any numbers in those lists at all? Okay, so some of you might have things like, let's throw some numbers in too. If you've got stuff in the lists, Put your cursor, well, get rid of it, yes. Put your, there's a kind of a specific way of doing it. Put your cursor up on top of the list. Press clear, the clear button, which is over here, and then press down or enter, and that clears the list out. You have to do it that way. If you press delete, which is the logical thing to push, it actually makes the list go away. Speaking of which, does everybody see L1, L2, and L3 up there? It's possible to remove them, and we have a fix for that. But if it's still there, then we're good to go for right now. You ready? Let's put Ernie in L1 and Bert in L2. And when I say put Ernie in L1, just simply type the numbers and press enter after each one. Hop over to L2. Stuck 10. This is the most tedious part of statistics. 61. The most tedious part of statistics, data entry. That's why copying and pasting from Excel, from documents to Excel is so nice. Less data entry. Cool so far? All right. Now, let's recalculate Ernie's measures, his statistics that we got last time. Okay, let's recalculate this. Go back to your stat menu and use your right arrow to arrow over once. Now you're in what's called your calculate menu, or CALC. Some of you, if you took Math 95 and/or Math 111, there's a little calculate menu up here too. But that's the graphical calculate menu, and that's a great menu, but it doesn't help us here at all. So the calc menu now, you got a bunch of stuff in this bad boy. I mean, there are I think a dozen commands, none of which we're going to use in here, except for the very first one. One var stats. What do you think var stands for? Variation. Oh, actually, variable. That's very nice. That's a stupid question. We were talking about variation this whole time, and I go, what's var stand for? Variation. It actually stands for variable because you're analyzing one variable, and the variable is Ernie's test performance. So I apologize for that question. That was a lame question. We're going to grab it though. Grab one var stats by pressing enter or by pressing 1, and what it does is it boots you out to the home screen. Okay? At this point, you can just press enter, and you get all kinds of good stuff. Some of it you'll recognize. Some of it you'll recognize. Look at this. Oh yes, you got it, Natalie. What's this guy right here? There's your average, X bar 81. What's this guy right here? Exactly! It's the sum of all the scores. You don't usually have to know that, or the next one down. That's the sum of the scores squared. Yeah, it's the sum of the squares of the scores, which is kind of weird. I mean, that's kind of, but the reason, I think TI includes these because some profs and teachers still make their students use those in calculations. So it doesn't really matter. I'm not going to make you do it. This is our favorite. This is what we spent 35 minutes calculating in class last time by hand. The sample standard deviation. We went through the x column, then the x minus x bar column. We noticed it summed to 0. Then we said, oh, let's square it. Then we squared all the deviations. Then we added the sums of the deviation squared. Then we divided by n minus 1, at which point you started dry heaving. Then we finally took the square root of the whole thing. And I said, we're done. And as you wiped away the drool from your mouth, you said, we're done, but what did we just do? And that's what I'm taking away by letting us use technology. We now go straight to that, which is about 1.6. But here's my question. Here's what I care about. What does that mean? What does it mean to have a standard deviation of 1.6 in your sample data?
Away from the mean, like the data points that were, it's kind of like the distance?
It's perfect, Natalie. It's the average distance of the data points from the mean. That's perfectly said. And that's the way I want you to think of it. We're going to add to that today, but that definition is never going to change. It's the average distance that a data point is from the mean of the sample. So there's your mean, 81. There's Ernie's data points, 80, 81, 83, 79, and 82. If you figure out how far apart those things are from the average, and average that, that's what your sample standard deviation is. Michael, you brought up last time the average deviation or the absolute value is a perfect indicator, but hopefully I gave you at least 1 or 2 good reasons as to why we don't use it anymore.
Well, we could just do the absolute value of the distances.
We I'm not saying we can't. I'm saying nobody does. I'm not saying we can't. I'm saying it's a much more logical thing to do. I'm also saying that nobody actually does calculations that way. It's unfortunate. It's a mathematical reason as to why. But people do it with the square and then unsquare versus the absolute value. The absolute value is way more understandable, but it's less accurate mathematically, which is why it's not used. Unfortunately, or I should say fortunately, you can think of it the same way. Basically, this operates almost exactly the same numerically, but it's off enough on average for them to use this more. That's the quick and easy answer. What's this? Remember what that guy is? That's little sigma. You got it. Remember what he was? That's baby sigma, little sigma, lowercase sigma. At the very end of the day, at the very end of class last time, I swung the camera over to that sideboard. I drew a little 2x2 chart. I got a great screenshot from that one, actually, from the camera. It's like JC's laughing at me. Probably was, that's okay. What is little sigma? It's the standard deviation in the... Good! It's the parameter. Who said that? That Jen. That was good. It's the parameter standard deviation, which means it's the standard deviation in the population. It's a standard deviation in the population, which is why we generally ignore it. Because this assumes your population has 5 things in it. Generally, you don't have a population in front of you, you have a sample in front of you. Which is why, until we get towards the end of this course, when the population makes sense to talk about, we're only going to look at that for standard deviations. We're only going to look at that for standard deviations. Patrick, go!
So the SX is standard deviation?
It's what we call little s. Your TI calls it s sub x, and the x is only because it refers to single variable data as an x. So what it calls s sub x, we just were calling s in class last time, just a little lowercase s. Same thing. Same exact thing. Is that fair? Just a terminology difference. Check it out. See how there's an arrow right there pointing down? Check this out. Scroll down. You get more goodness. A lot of which isn't going to be all super important to us right now, but the one that's really nice is the median. That gives you the median without having to sort the data, without having to do any crisscrossing or anything like that. That's extraordinarily nice. JC, I've enjoyed our time together slashing the numbers, but we don't need it anymore. Now we use technology to do it for us. Good. Q1 and Q3, we'll deal with all that in turn. It doesn't make it's not tight enough to center to get to just yet. We'll come back to all that Q1s and Q3s. We'll get back to it, I promise. I promise. We'll get. Have you seen them before?
Yes, I have.
Yes, you have. You have, Leslie. Good. We'll get back to them. They're like medians, but we'll talk more about that when we talk more about percentiles versus absolutes.
I'm so glad about the standard deviation on the calculator thing.
Oh, it's huge!
I did that by hand before.
Oh, yeah! And like I said, one time is enough. One time is enough.
Yeah.
One time is enough. Now, so Ernie's sample standard deviation is about 1.6. Let's do Bert's. So hit clear. Hit clear. Remember where that calculation button was? Stat. Calc. It's still one of our stats. But you can't just press enter again, because if you press enter again, you get the exact same stuff you just got, which was Ernie. What you have to do is you have to tell it to go look at L2. And the way we do that is, I don't know if you can see it on your keypad. You see L1, L2, L3, L4, L5, and L6 down here? You got to press your second function button. Second function button, and then the number 2. And that'll call up L2 for you. You don't have to do L1. It assumes you're using L1 if you just press one of our stats. Cool? Enter. Some of this looks the same, but some of it should look the same, because Bert and Ernie had the same mean. Exactly, Heather, they had the same mean, which means they have the same sum of total points, which means they average out to 81, but it starts getting different right after that. It starts getting different after that, and the big indicator is right there. Where Ernie was only off of his average by about 1.6 points, Bert's off by 10 times as much. And that was indicated by how spread out Bert's scores are. His range was almost 10 times as much, the standard deviation, the distances were almost 10 times as much. So we satisfied our restrictions. We wanted a measure that got bigger as data got more varied. And we got it. We've got it. This is the uniformly accepted one. Although range does too, average deviation does too, they all do. This is just the one that's uniformly accepted for mathematical reasons. And you can go down and get all the other stuff you need, the medians down there and all that good stuff as well. And we'll talk more, again, we're getting to the point, like why is Q3 97? Why is Q1 64.5? He didn't even get a 64.5 or a 97. We'll get to that, I promise. That's like next week, beginning of next week, end of next week, somewhere in there. But right now, I really am just excited about this, the fact that we get this for free. And I want to go one step further with that today and make sure. But is everybody okay with the technology? I like having this on record, that way we have the button pushes that we can refer back to it in case you need it. And I'm going to try, I doubt I'll have time to make these myself, I'm going to try to start hyperlinking videos in to the Hellberg page with TI steps. I'd like to think that I can do it myself and hyperlink them up, but I doubt very much I'm going to have time to do that, plus all the other video recording, so I might just find somebody else that's already done it and link those in. Cool. Anyway, make sense? Technology good? Good. Let's put it to use.